Assalamualaikum warahmatullahi wabarakatuh and have a good day. Okay, so today this class we will learn about the power dissipation in AC. Okay, AC circuit. So previously you learned that in DC, okay, DC, okay, you have P equals to VI. That's it. Okay, this is power. Okay, only power. P equals to VI for DC. But for AC is very different. Because of the complex component in AC, there is a lot of things that you need to know when it comes to AC. Okay, first, real power. So what is real power? So real power, you assign P equals to V RMS, okay, or basically V I cos theta V minus theta I. Okay, so real power. So Vi cos theta V minus theta I. So real power is basically the power that is lost to resistor. Okay, so Vi, okay, for example, you have V equals to, okay, this one should have absolute, okay, V absolute angle theta, okay, and I is usually I absolute angle theta. So theta V, this one theta I. Okay, for example, you have V, you have I, then to calculate the power you have to include absolute V, absolute I. Okay, cos theta V minus theta I. So this will become the power loss to resistor. Next thing you need to know is the real and reactive power. So what is reactive power? Is basically power that is lost to L and C. Okay, the power that is lost or gain, okay, or gain to L and C. Okay, so for this case, actually L, the power, reactive power lost to L, and for capacitive it, so for C it will supply reactive power. Okay, remember L is for absorb, okay, absorb, C is supply, okay, supply Q, which is reactive power. Okay, so remember for reactive power, L absorb reactive power, absorb Q only, and C absorb L, supply Q only. So the formula almost the same. Okay, V I sine theta V minus theta I. Okay, for this one the unit is watt. Okay, W. But for this one, okay, the unit is VAR. Okay, voltage, current, and reactive. Okay, remember VAR, the unit. So just remember when you put Q is VAR. Then lastly, it is apparent power. Okay, the apparent power is basically, the apparent power is S. Okay, S is apparent power. So what is apparent power is just basically S equals to V and I. Okay, it's combination of all the power. Okay, R, L, and C. It will combine together. This is the formula. Okay, so you have three types of power. Okay, so P equals to VI cos theta. Reactive power is VI sin theta. Okay, theta is theta V minus theta I. S equals to VI. Okay, and one more thing you need to know that usually theta is the theta V minus theta I. Make sure you know that voltage minus current. Okay, is standard. Okay, so you have all of this. So how you can relate to this? So basically, if you draw this in the inline, okay, it's called power triangle. Okay, power triangle. So basically, P is this, Q, okay, is this, and S is this. Then this is the theta. Okay, the theta. Okay, that is the relationship. This is called a power triangle. This is for positive Q. Okay, for P is always positive to the load. Okay, for the load is P is always positive, but for the load Q can be changed. Sometimes it is negative. Okay, so P, Q is negative Q, and lastly is S. Okay, S is also always negative because of the absolute. So this is the theta. So you need to know the formula P, Q, and S, and also how to draw the power triangle. This is 90 degree. This is also 90 degree. And you need also to know this one. Okay, that is the relationship. Okay, that is the difference between DC and AC. So you have 1, 2, 3. Three types of power. Okay. So, okay, you already know three types of power. Now this is the important one. Okay. Then you have an additional thing you need to know. Okay. Okay. Let me choose green. Okay. So, apparent power, reactive power, real power. Then you need to know the okay. Okay, this one is actually okay. Complex power. Okay. So what is complex power? So complex power is also S. Okay. But instead of this one is only real number, but complex power is complex number. Okay. Real and complex number. So also S. Okay. So for sign, I think you can use either. Okay, it's the same. Actually, you need to differentiate it, but for this class, I just accept it if you change it. But depend on the question. Sometimes they ask about the real power, the complex power. Sometimes they ask the apparent power. So you have to be careful. So what is S? Okay, for complex power, what is S? Okay, S is basically P plus JQ. Okay, so basically S is P plus JQ, and I forget to tell you this one. The unit is VA. Okay, so the unit for P is watt, Q is VAR, and S is VA. Okay, this one apparent power is VA, voltage ampere. That's it. And for this case also, the unit is VA. Okay, then S equal to P plus JQ. Okay, sometimes S also can be Okay, S equals to VI conjugate. Okay, what is mean that VI conjugate is that you look here. Okay, you look here. Okay, S is equals to VI conjugate equals to VI. Okay, then angle theta V minus theta I. Okay, because of the conjugate, it will become negative. So, for example, I equals to I angle theta I. So, I conjugate means that you have to add negative. That's it. Negative theta I. So, when you multiply this one become multiply. So, this one become plus. Or for this case, because of the conjugate, it become minus. Okay. So, you can either use this formula or this formula to get the complex power. And also another point is, okay, so S, okay, you see that VI. Okay, another way is, okay, okay, wait, my pen doesn't work. Okay, okay, so beside this, you also can use, okay, V squared over Z, okay, conjugate, or okay, I squared, okay, absolute power I squared Z, okay, Z. Okay, so you have to memorize this formula because that it will not be given in your, okay, in your sorry, in your test or exam. Okay, so how to memorize this? Okay, so if I draw this again, okay, so real, okay, complex. Okay, you need to know the real number is just basically this one. Okay, this value. Okay, this one is real number. Okay, okay, sorry, this one is real number, this one is real number also, and if you consider all of it, okay, consider all of it, it is complex number. This one is complex number. So complex number have complex component, real number is only the real part. So if I write this again, okay, so complex S equals to VI complex equals to, okay, this is real number, okay, okay, squared, so divide by Z, okay, conjugate equals to I squared. This one is complex. Okay, make sure you remember which one is real, which one is complex. If you use this one, okay, if you use this one, make sure all of it complex. If you use this one, V is complex, and if you use this one, is only I is a real number. For this one, okay, for this one is only V is the real number. Okay, how about conjugate? Okay, so easiest way to remember is when it comes to conjugate, each time there are voltage, okay, if there are voltage, you need to conjugate the other component. Same as here, if you have voltage, you will need to conjugate the other component, which is Z. For this case, there is no voltage, no need to conjugate. So that's it. for real complex for complex number. Okay, so basically you have to memorize this. And then lastly, okay, is also p, okay, plus, okay, j q. Okay, so for the unit is remember the unit is VA. So this is the formula. So you have to memorize everything. Okay, so what is next part? Okay, you have PQ. Okay, you have P, you have Q, you have S for apparent power, and you have S for complex power. The next thing you need to know in power for AC circuit is power factor. Okay, so what is power factor? Okay, so if you remember the power factor, okay, so remember that I is equal to, okay, so V equals to V absolute theta V, and I equals to I theta I. So power factor is, okay, and remember theta is equals to theta V minus theta I. Okay, you just take these two together and put here. So what is power factor? Power factor, okay, PF is just basically, okay, it's just basically cos theta. That's it. Okay, okay, that's it. Power factor. Then lastly is the instantaneous power. Okay, so I change this. So basically what is the difference is, for instantaneous powers it is in time domain. Okay, for all of this, okay, for others, okay, for real power, apparent power, okay, instantaneous power, it's usually in phasor domain, but instantaneous power is changed with time. So different time will give different power. So for this is usually PT, okay, equals to VT IT. So you have to define VT is Vm maximum voltage, okay, cos Wt plus theta V, and IT equals to Im cos Wt plus theta I. So you just multiply this together, you get instantaneous power. So how to multiply? So for this case, you have to check back your slide. Okay, instantaneous power. So P, as I mentioned before, P is equal to VT IT. Okay, this is the definition of VT and IT. And then after you multiply, you use the identity. Okay, cos A cos B is equal to half cos A minus B plus cos A plus B. Okay, so then, okay, if I open this slide bigger, okay, if you look here, okay, this is using the identity, then you apply it, then lastly you get PT is basically real power. Okay, real power come from here, 1/2 Vm Im cos V2 theta v minus theta I. Why Vm Im cos half? Okay. So how to do this is basically, okay, remember that this one, okay, if you change to phasor is Vm minus square root 2, okay, equals to V RMS. Okay, so I RMS is basically, okay, basically square root 2. Okay, so what happen if V RMS RMS is basically Vm square root 2, okay, multiplied by Im divided by square root 2, so you get Vm Im divided by 2. That is why this parameter here becomes P. Okay, because when you change it to phasor, you need to use RMS. So it will become P for this case. Okay, this one you cannot do anything. So P cos WT, and make sure you know this one and this one. Okay, you have power, real power, and then you have a changing component. Okay, this is the P component, and this one is the sinusoidal component. Okay, so why this is important? Because in theory, usually this will ask in a theory part. Okay, you need to memorize the how to derive this, because sometimes they will ask in the theoretical part, and sometimes they ask you to find the instantaneous power. For example, they give the power, okay, for example, they give the power and they give the frequency, okay, find the instantaneous power. So I give you example of the instantaneous power. Okay, where is it? So for example, the load use 1000 watt. The frequency, angular frequency, is 300 rad per second. So what is instantaneous power? Okay, and okay, what is instant? Don't forget Q. Okay, what and 500 VAR. Okay, so what is the instantaneous power at 3 seconds? Okay, so you have to memorize the formula, which is PT is equals to P plus P sine cos 2W minus Q sine 2W. So don't forget T. Okay, so you just insert this value into the formula. So let me check first. Okay, so just insert this value. Okay, you get instantaneous power at certain time. Okay, so that's why you need to memorize this formula and not how to derive it, because it is usually asked in the theory. Okay, and sometimes they give the formula, for example PT. Okay, for example, they give a question PT equals to 200 plus 200 cos 600 T, okay, minus 300 sine, okay, 600 T. Okay, so from this you need to find what is P, what is Q. Okay, so from this equation you need to extract the P and Q and angular frequency. Okay, so that is how the question around instantaneous equation is asked. So you need to know. So that's it. So you have, okay, P, you have real power, complex power, apparent power, real power, reactive power, apparent power. Then you have complex power, you have power factor, and lastly you have instantaneous power. So you have to know the formula and know everything. Okay, so basically AC, okay, AC circuit is very complicated. You have to memorize everything, okay, every power. Okay, this is all for today. Thank you.